Hello. So, welcome to this next lecture on computer networks and internet protocols. Today, we will be discussing one of the important application layer protocol, namely DNS, right. This DNS helps us in resolving name to IP conversion. So, we will go on looking at it. So, as if you just quickly recollect, so we have seen this application layer, there are various protocols, right, like some related to file transfer, email, remote login, network management, and there is a name management or name resolution, for name resolution, which is DNS. So, domain name systems, FTP, hypertext protocol, and so forth are some of the important protocols. Today, we will discuss on domain name system or DNS. So, what is DNS? It is a sort of a global database for internet addressing, mail and other information. So, why suddenly we require this? Now, you see, whenever we want to communicate one packet or one data packet from one to another, what we require? We require primarily the IP address of the destination, right. So, especially when we do internet networking, the IP address is the of the destination what we require. Now, remembering IP address is a tedious job, right. If you want to say, if you want to open IITKGP www.iitkgp.ac.in, and instead of this, if I say that you remember the IP address of IITKGP at 203.16. So and so forth, it is very tedious to remember. So, in other sense, whether I can have some naming convention. So, that means some names which in turn can be resolved to IP, right. Now, on the other, if you see the routers which can open up to or look up to network layer or IP will not understand these names, right. Names can be only understood at the application level, right. So, routers should be given data in form of IP only. So, I require somebody who can convert this name to IP, that exactly the job of primary job of DNS. DNS does some few more things that we will see, but primarily it works on this resolving name to IP. So, there is a concept of domain and subdomains as in a sense that how much I will cover in my DNS. So, suppose IIT Kharagpur DNS, so what is its responsibility, whether it will take care the IITKGP as its domain can have subdomains and so forth, like we IITKGP.ac.in, it may be a domain, csc.iitkgp.ac.in a subdomain on the things and type of things, and there are concept of DNS servers which translate the domain name to the IP address. So, one is that management of this distributed domain, another is that I require domain name server which will translate this domain name to IP addresses, right. These two are the primarily one of the major activities of the things. So, we have seen there are some of the top level domains or what we say TLDs like com, org, net and so forth. Typically, these top level domains are 3 character length, and there are few country domains. There are rather for every country there is a country domain which are a 2 character length, like in for India, US for US United States of America, and CA for Canada and so forth. So, these are what we say top level domain, so or TLDs. Now, if we like to see the domain namespace, right. So, the domain namespace is something like that. So, we have some of the top level domains like ARPA, COM, EDU, ORG and so forth, and then under that I have subdomains, like suppose India, under India there are AC, under AC IITKGP, under IITKGP CSC. So, that is the overall domain namespace, right. So, that those domain namespace need to be defined. Now, so that above the TLD what we do or is the root domain. So, what we have, say if this is a typical example of say Challenger or ATC FHDA.edu. So, this is a overall domain name. So, if we go on this hierarchy, so the next level is this one, next level is fhda.edu, and edu is the top level domain. This dot indicates the root domain. So, these are the top level domains which are there, which is there. So, this typical example may be from Frozen or Stalling books, you can refer that, but nevertheless this is the hierarchy of the things. So, see, the manageability of the name has been done in this way. Now, at the every level there is IP address. So, if I want to resolve, if I want to go to this domain, I need to resolve. So, there should be somebody who will resolve, as we know about this client server thing. So, the say I give www.iitkgpac.in in my browser. So, browser is a client or HTTP client which requests my DNS for a resolution, right. So, give me the IP sort of thing. So, the DNS resolve and send me back the IP address. Taking this IP address, the rest of the communication goes on. Intermediate routers and other devices understand the IP address, right. At the end, it will be delivered to the destination IP address. Now, if we look at this domain, so this is a domain, this is a domain, this is a domain, and there are different. So, this .com has the responsibility of the thing, and if it is having another intermediate thing, then it has to go for other domains to look at, and so on and so forth, right. So, every domain server or the DNS server have some record of what it is under that, right. That we will see, that we call that it has a resource record. So, what are the resources it is having, right. So, it has the, or it has a some sort of a control authority of the domain. It can have subdomain, it delegate that thing to the things, right, and go so and so forth. Similarly, here also in the edu case we see this one. So, if I have csc.iitkgpac.in, then in ac iitkgp csc, like this is the top level domain, country domain, and above that is the root domain dot, which is dot. So, domain names are arranged in a hierarchical tree like structure. So, see, I can have multiple CSC at some level. There are also CSC, IITB also have a CSC, but the overall thing will not disturb, right. So, individually IITKGP, only if you look at the CSC, so that may clash, like every IIT or every IIT has a CSC department and their domain names are CSC, and it will clash, but that is partially qualified or partially defined. But if I have a fully qualified csc.iitkgpac.in, this will never will be duplicated. So, that means I can uniquely define that thing and uniquely define that IP address of the things. Now, that is why we have a fully qualified domain name, that if a domain name ends with a dot, it is assumed to be complete. This is called fully qualified domain name, or FQDN, or an absolute domain name, right. Like it should be iitkgp csc.iitkgp.ac.in. So, that means fully qualified. Only if I see only csc.iitkgp, this is partially qualified. That means you require something to make it fully qualified. If a domain name does not end in a dot, it is incomplete, and the DNS resolver may complete this by appending a suffix to this domain. The rules for doing are implementation dependent and locally configurable. So, how you will be there, so the DNS server can make it fully qualified before going to the other things. So, we have some generic TLDs, as we are discussing, that top level domains. Top level domains are called generic TLDs or GTLDs sometimes, and can be 3 characters or more in length. So, there is the top level domain, typically 3 characters, or there are arrow etc., which is 4 characters. These names are registered with the and maintained by a what we say authoritative agency, or what we call at ICANN. So, these are top level domain which has 3 plus 3 or more characters, can be are defined by the ICANN. Now, these are some of the example of top level domains, like arrow, bees, etc., that is minimum 3 character. Even there is a top level domain called museum, which is much more than that. There is a concept of country domain. Top level domains named for each of the ISO 3166 international 2-character country codes. So, that everybody has the things like AE for United Arabs, IN for India, AU for Australia and so forth. These are the country domain or the geographical domain. So, it is country specific. Many countries have their own second level domain underneath the parallel which parallel generic domain name this top level domain, right. Like what we say like AC.in, right. So, there can be AC dot or what we say co.in. So, there can be some other domain where that is co dot say something edu is can be there, right, or something. So, so what we having iitkgp.ac.in, these are underneath that in domain. Now, this distribution of domain space, right. So, if we see, so if the root server primarily understand the top level domains. Now, if there is any resolution, it will go to that next level domain. Say if there is a request coming from something.com or something.edu, it will send it to the next level server, which resolves the next level things. So, every domain server has their particular authoritative zone where it keeps the information records regarding that zone, right. So, while resolution it helps in doing that. Now, this hierarchical structure allows me to expand or add, delete, update type of things, right. So, if there is a update in say somewhere bk.edu, so that that server or edu.server understands, so the root server sends it to that, right. So, it depends on where, like IITKGP tomorrow opens up a new domain, it basically put it into its own resource record of iitkgp.ac.in domain name server, which in turn are resolved when a request for that particular subdomain comes into play. So, that means we have zone and domain. So, this is a domain. So, that is one zone, this is zone and domain in the same. So, that means it takes care of that where the authority is there. So, the data for which it has the authority, so it responds with a authoritative answer or it responds with a non-authoritative answer, if it gets update from somebody other domain. So, what is a zone? Domains are broken into zone for which individual DNS server are responsible. So, a particular domain is broken into zone for which individual DNS servers are responsible. A domain represents the entire set of names and machines that are contained under a organizational domain name. So, a domain represents the entire set of name like iitkgp.ac.in. So, it takes care of the entire set of name and machines or names versus IP address that are within that particular domain. A zone is a domain minus the subdomain delegation to the other things. So, it has delegated the server like AC.in domain has delegated that IITKGP related to the IITKGP.ac.in. So, that domain of that particular AC.in is restricted to the things which exclude its like minus those or excluding those subdomain delegated to other DNS server if at all. So, conceptually each domain name is typically served by 2 or more DNS servers for redundancy. So, if there is a failure of one DNS, others should be able to resolve. So, again the resolving means primarily mapping from name to IP. So, if the one of the server fails, the other server takes up the responsibility. Only one DNS server should be configured as primary of a zone. The primary server contains the master copy of the data of the zone. Secondary servers can get copies of the data through a zone transfer. So, there is a intermediate things which goes on to the zone transfer and goes on for this sort of update to the secondary servers, right. So, there can be one or more secondary servers. So, but nevertheless the master record is with the things and the secondary server gets synced or transfer of zone from the primary to secondary. Zone transfer, a primary server loads all the information from the disk, the secondary server loads all information from the primary server. When the primary downloads information from the secondary, it is called zone server. So, it is required the zone transfer if there is a need like that. DNS in the role of DNS in the internet networking or DNS in the internet. So, there are three categories as we have seen: generic domain and country domain. One is 3 or more and one is 2 character length. Now, there is a third category called inverse domain or reverse domain, right. So, that is these are all domain name to IP. If there is a inverse is required, name to IP to domain, then we have a inverse domain database, right, or inverse domain server which does a inverse domain resolution. Like for generic domain, like in this chal.atc.fhda.edu. So, in this path it is defined. So, it is chal adc fhda.edu chal adt fldl edu right. Similarly, any other paths will be defined. So, for country domain, like here also the paths are defined like that. For inverse domain, if it is a IP to this, so the IP and IP this basically this server is in addr.arpa.net, in addr.arpa, and the IP is written in a reverse way. So, 132.34.45.121 is written here either 121.45.34.132 in a DDR and ARPA.node. So, the IP representation in a inverse way. This is inverse resolution, right. So, it is if the IP is there, it basically sends back the name of the things. Usually primarily we have forward resolution, this is a inverse resolution. Name resolution, the commonly used server is bind, that is Berkeley internal name domain, runs under Unix or Linux as a process and called named. So, that means named is the daemon, which is the DNS daemon. When an application needs some information from the user, it invokes DNS name resolution resolver. So, it resolves the name. The DNS translates a fully qualified domain name into a corresponding IP address using the command called ns lookup. So, when we give ns lookup, then it is resolved into the particular resolution. You can pretty easily use any command from this one. So, if the name server does not have a information locally, it asks the primary server and so on. For the redundancy, each host may also have one or more secondary name servers which may be queried when the primary fails. So, that is the command is ns lookup. We can have a quick look into the thing, so that it will be say CMD. If I give hopefully the ns lookup, suppose I give www dot first of all iitkgp.ac.in, it will returns the IP address as I am a locally accessing it. So, it gives me the local IP address. Suppose I give some other things like www dot say something like nic.in. So, I get a resolution for that, whatever it is showing is the IP. Similarly, www say google.com. So, it resolves the Google IP as 216 this. So, this type of what it is doing, it is asking the DNS server give me the name. So, it is some sort of a resolution process which is going on, right. So, this is the hierarchy as we have seen of the domain names, and if the resolution goes on. So, there can be recursive resolution. Name server asks to edu that what it wants to resolve a particular client under that FHDA. So, it go on resolving it request goes on the things and resolving in a recursive way. So, it go on recursing, one name server asks the next and go on recursive way, or it can be iterative. Client subsequently send queries to the DNS server and receives the resolution. If response is negative, DNS server to query the next is also returned. So, if it is not having, it returns that where DNS to be queried, unlike recursive resolution here where only one response is the finally returned by the thing. So, in the recursive that itself recurs to the other. In case of iterative, it sends that if it is not having, sends the next that address of the next DNS server. So, it is some sort of a what we are discussing as the recursive resolution. Now, if I want to resolve a particular DNS, if you look at the DNS resolution or resolver point of view, so user program send a query user query to the full resolver. It in turn send to the name server, it get results response and in turn give the user response, right. The DNS the full resolver maintain a cache by which it remembers that what is the mapping. So, that it does it next time much faster, whereas the name server has a if it is has a own database and cache, and if it is not having, it goes to it sends it to the other name server or foreign name server, right. This is a full resolution. So, the user program in turn send to the full resolution and get it done. There is another resolver which is pretty popular, that is called another way of resolving, that is a stub resolver. The stub resolver has a routine linked with the user program that forwards queries to a name server for processing. So, it is a routine attached with that process itself. So, on most platforms the sub resolver is implemented by two library routines or some variation of these, like get host by name is the routine, most of the Linux systems supports it, and guest host by address is another routine. So, in this case the resolver is embedded in the user program, unlike that full resolver, and then it goes on directly hitting to the name server. So, it is much faster and popular and mostly used. DNS, now let us come to the DNS messages, right, or also we call the DNS, there is a concept of DNS resource records before going to that messages types. So, domain name systems distributed database is composed of resource record RRs, which are divided into classes for different kind of networks, right. So, this is the thing. Resource record provide a mapping between the domain name and the network objects, right. So, domain name and the network objects give a mapping. That is interestingly, if you see say IITKGP.ac.in, it can be a domain, it can be a domain server, it also can be a HTTP server, or I can have a FTP server where that. So, that is a record that which says based on that mapping that what sort of request I can map to that particular network object. The most common network objects are the addresses of the internet host, but the domain name is designed to accommodate a wide range of different objects. So, that means it is not only the host IPs, but it is something much more than that. So, it is a concept of resource records, right. So, a zone consists of a group of resource record beginning with a start of authority SOA of the record. So, it is a particular zone has a group of resource record, but it starts with the start of authority, right. There will be a name server NS record for the primary name server for this zone. There may be also NS record for the secondary name servers, right. So, there can be NS record for the primary and as well as secondary. The NS records are used to identify which of the name server are authoritative. So, it is whether it is authoritative or non-authoritative determined by this NS record. So, that whether it is itself maintaining it as the authority of the thing, or it is basically updated from somebody, some other name server. So, typical structure of these resource record, we will see some example: name, type, class, TTL, time to live, and RD record, RD length, RD data. So these are the typical structure of the resource record. This is a typical format of a RR message format, where some identification is required, parameter, query count, answer count, a total number of NS count, and this AR count, right. So, these are record count, so that we have the question section, answer section, authority section, and additional information section. So, this compromises a RR message format. So, whenever this RR message is being exchanged, so these are the things which are used for when we do. So, this format goes on. That means, the DNS clients and servers or DNS zone transfers, this is the standard which is followed, so that everybody understands the other message. DNS message is typically of two things. One is query, another is response, right. So, query response type of things. So, the query has a header and question section, whereas the response is having a header, question section, answer section, authoritative section, and additional section. So, this is the responses goes on the thing. So, there is in the header format, there is a two thing is identification and flags, along with the number of question records it is sent, number of answer records, all zeros, because there is no answer record in the query. So, it is all zeros in the query message, number of authority records, again all zeros in the query message, a number of additional records, all zeros in the query message. And there is a flag field, if you just recollect. So, there is a flag field, we just see that one, that is QR, that is whether it is it indicates whether it is a query or response. Opcode 0 for standard, inverse, or server status. So, that is the operational code. It is a standard, meaning that is name to IP, IP to name is inverse, and then server status. If it is authoritative, then this flag is A is on, TC is whether it is truncated or the full record is sent, RD is the recursion desired, RA is the recursion available, and R code is the status of the error. So, these are the different formats of these flag fields, and the type of records, as we mentioned, there is record one is the query name, query type, and query class. Like here query name format, suppose we want to have that admin.atc.fhda.edu. So, it says the number of count is 5. So, that admin 3 and so forth. So, it says that which are the different names which are separated by dot by doing that. So, this is the query name format, and resource record format we have seen already, that domain name, domain type, domain class, time to leave, resource record data length, and the whole resource record. So, let us see one or two examples. A resolver wants a query message to a local server to find the IP address of the chal.fhda.edu. We discuss the query and response separately. Let us discuss. So, this is the typical format where you see that it is encoded. These are the different fields. So, it is a query message and other things are 0, and this is C 4 CHDA CHAL, then again 4 FHDA 3 EDU, and 0, that means that is the end of the things, right. So, it has a if it is a large record, that continuing on the next line or not, and so forth. Similarly, example of a response is query message is there, and along with that response message is also there, right. If you can check that particular IP, so it is 153.18.8.105. So, the response message which is read by the system, and it is the DNS is resolved. Similarly, example 2, an FTP server has received a packet from a FTP client with a IP address 153.2.79.9, the FTP server wants to verify the FTP client is an authorized or not, right. So, it is getting a IP and now it wants to verify whether it is authorized or not, like in other sense that it wants to know that particular which domain has this particular IP, right. So, this is the FTP server wants. So, FTP client has requested and FTP server wants to do that. So, it is a reverse query message. So, it goes on if you look at, there is ARPA dot this is RDDA ARPA dot ADDR slash dash in dot the IP in a other way around, right. So, if I have 9.7.2.153, so here 9.7.2.153 dot I in minus ADDR dot ARPA, right. So, this is the way it resolve, and inverse response file is return the particular name of the thing, which is written, it is mhhe.com is the name of the particular domain. So, why we require this? The FTP site server wants to authenticate or wants to know that whether the IP where from it is getting a request for a file transfer request or FTP request, then whether that is a authorized or not, and it does as a reverse domain resolution. Okay. So, what we see overall, that domain resolution is primarily for IP to domain name, a name to IP, and it is easier to remember name than IP. So, that anywhere we use the name, if the request is going across the internet, it has need to be resolved. So, the domain resolver that every particular domain subdomain can have will have a DNS server, which basically resolve this. When the request goes to the DNS query, it resolve it, right, and it it sends back the result thing. There is a concept of inverse DNS, where if you give the IP, it returns that domain of the things. It may be required for authenticate or see the authority of a particular domain. So, with this let us conclude our discussion today. We will continue on this particular topic, or basically on application layer for one or two more lectures. Thank you.